Bismillahirrahmanirrahim. Assalamu alaikum. Our today's topic is about chemical equilibrium. Now let's dive in a topic. Before starting chemical equilibrium, we must know what are chemical reactions. Chemical reaction is the process in which one or more substances, that is, the reactants, are converted to one or more different substances, the products. Substances are either chemical elements or compounds. A chemical reaction rearranges the constituent atom of the reactants to create different substances as products. For example, burning of wood is a chemical reaction. Example 2. When ammonia react with boron trifluoride, a new substance, that is ammonia boron trifluoride, is formed. Now daily use chemical reaction, that is combustion, rusting, digestion, photosynthesis, batteries, fermentation, washing and baking. There are two types of reaction, that is reversible reaction and irreversible reaction. In reversible reaction, reactant converts into products and products again convert into reactant. This reaction takes place in both direction, that is forward reaction and reverse reaction or backward reaction. Now irreversible reactions. A fundamental concept of chemistry is that chemical reactions occurred when reactants reacted with each other to form products. These unidirectional reactions are known as irreversible reactions. Reactions in which the reactants convert to products and where the products cannot convert back to the reactants. These reactions are essentially like baking. The ingredients acting as the reactants are mixed and baked together to form a cake, which acts as the product. This cake cannot be converted back to the reactants, that is the eggs or flour, etc. Just as the products in an irreversible reaction cannot convert back into the reactants. An example of an irreversible reaction is combustion. Combustion involves burning an organic compound, such as a hydrocarbon and oxygen, to produce carbon dioxide and water. Because water and carbon dioxide are stable, they do not react with each other to form the reactants. Combustion reactions take the following form. When hydrocarbon react with oxygen, they form carbon dioxide and water. Reversible reaction. Chemical reactions that take place in one direction only. It goes on until at least one of the reactants is used up. For example, reaction between sodium and water to form sodium hydroxide and hydrogen. In this reaction, water molecules are present in excess. Reaction proceeds in forward direction until all the sodium atom is used up. Now reversible reaction. A reversible reaction is a reaction in which the conversion of reactants to products and the conversion of products to reactants occur simultaneously. Now reversible reaction, when the reaction occurs both forward and reverse direction, it is called reversible reaction. In many reactions, the products interact and revert back into the reactants. For example, SO2 react with O2 to form SO3. during forward reaction. And in reverse reaction, SO3 again decompose and convert into SO2 and O2. Example 2, COCl2 decompose into CO and Cl2 in forward direction. During reverse reaction or during backward direction, CO react with Cl2 to form COCl2. Example 3, N2 plus O2 react together to form NO, and in backward direction NO again decompose into N2 and O2. Now chemical equilibrium. At chemical equilibrium, rate of forward reaction becomes equal to the rate of backward reaction. These are some more examples of reversible reaction which occurs in both directions. It is the graph between time and rate. At zero time, rate of forward reaction occur. And as the time proceeding, rate of reverse reaction also occur, and at equilibrium, rate of forward reaction becomes equal to the rate of backward reaction. Both reactions occurs at equal rates. Now it's the graph between time and amount of substances, that is molar concentration. At zero time, the concentration of reactants is maximum. As the time proceeding, reactants convert into products. And at zero time, the concentration of product is zero. As the time proceeding, the concentration of products increasing. At equilibrium, no change in the amount of reactant as well as the amount of products. At equilibrium, the concentration of reactant and products remains constant. These are the illustration of reaction between nitrogen and it is the decomposition of N2O4. N2O4 decomposed to form NO2 during forward reaction, and during backward reaction NO2 again react to form N2O4. At equilibrium, the concentration of both the reactants and the products remains constant. Consider the generalized reaction in which reactants A and B react together to form C and D. These are the coefficient of the substances. Now, law of chemical equilibrium. This law states that at a given temperature, a chemical system may achieve a state in which a ratio of reactant and product concentrations has a constant value. The general equation for an equilibrium reaction is A plus B react together to form C and D, and during backward reaction C and D react together to form A and B again. Now law of mass action. The law of mass action states the rate of a chemical reaction is directly proportional to the product of the reactant concentration values. The law gives a formula for the equilibrium constant, that is Kc is equal to C into D divided by A into B. For the reaction A plus B react together to form C plus D. Equilibrium constant. The law of mass action suggests that the ratio of the reactant's concentration and the product's concentration is constant at a state of chemical equilibrium. Now A plus B react together to form C plus D, and during backward reaction C plus D react together to form A plus B. Rate of forward reaction is directly proportional to the concentration of the reactants, which is equal to rate F is equal to Kf and the concentration of the reactant. And rate of reverse reaction is directly proportional to the concentration of the product. After removing the sign of proportionality, we get rate of reverse reaction is equal to Kr Cn into D. At equilibrium, rate of forward reaction is equal to rate of reverse reaction, which is equal to, it is the rate of forward reaction, and rate of reverse reaction is equal to the product, that is Kf C into D. By rearranging the equation, this equation, we get Kf over Kr, which is equal to Cd over AB. Kf over Kr is the ratio of rate of forward and the rate of reverse, which is equal to Kc, that is equilibrium constant, which is equal to Cd over AB. In general, Kc is the ratio of the products and reactants. The equilibrium constant K equilibrium or Kc is the ratio of the concentrations of the products to the concentrations of the reactants at equilibrium. Each concentration is raised to the power of its coefficient. The concentration, the chemical equilibrium, that is K equilibrium or Kc is equal to C. These are the coefficient of the products and A, and these are the coefficient is raised to the power of the reactants. The concentrations of each substance indicated by the square brackets around the formula are measured in molarity unit or mole per liter or mole per dm cube. Write the equilibrium constant of the following reaction. The equilibrium constant of this reaction, which is equal to the product of the active masses of the product divided by the product of the active masses of the reactant. So for the reaction, N2O5 form 4NO2 plus O2. Its chemical equilibrium is expressed as NO2 power 4 into O2 power 1 divided by N2O5. Its coefficient is 2 is raised to its power, because its coefficient is 2. It is the equilibrium constant expression of this reaction. Thank you very much. Allah Hafiz.